All right, Unit 7, Lesson 2, Investigation 2, Law of Cosines. To get us started, I want you guys to look at these two triangles. In this triangle, we need to find KS, which is this side up here. In this triangle, we have to find angle F, which is that angle right there. Now, last week, we learned about the Law of Sines. Right? Could we use the Law of Sines in either one of these problems? I want you to take a look at them real quick.
Yes.
And sit and think about it for a second. Take a look and think whether or not we could use the Law of Sines.
No.
Travis, you still think yes?
No. No.
No? Why not? Why is it no now?
Because everyone else says no.
Everyone else says no.
There's
Okay.
no little letters.
There's no little letters? Okay, even if there were little letters. Little letters represent what?
Side.
Sides. In order to use law of sines, we need to know the big letter and the little letter, right? We call those angle side pairs. So here, E and 8, those would be an angle side pair, wouldn't they?
Correct.
Yeah. Do we know both of them?
No.
No. So can we use law of sines?
No.
No. Okay. Over here, H and this side right here, we could call little h. Maybe an angle side pair, right?
Yep.
Yeah.
We know both of them?
No.
No. So do we know any angle side pairs in either of these two triangles?
No.
No. Is there any way to find them?
No. Yeah.
I can't find any of these angles, can I?
No.
Not yet. Okay. How am I going to find the hypotenuse? Okay, good. You were thinking Pythagorean Theorem, weren't you?
Yep.
Okay. Travis was thinking we could use Pythagorean Theorem for this. But is it a right triangle?
No.
No, it's an obtuse triangle, right? Because our angle is bigger than 90. So we can't use Pythagorean Theorem. Can we use angle sum theorem on this triangle? No, because we only know one angle, right? So what should we use, Jared? Law of cosines, good. These actually represent the two situations in which you can use law of cosines. Okay, you can think of it this way: that law of cosines is kind of the catch-all law for all the triangles. Right? We learned SOHCAHTOA only works for 90-degree triangles. We learned law of sines works when we have an angle and a side pair. Right? Law of cosines works for the rest of them. All right. So these are our two situations, and we'll come back to them in a second. There is no law of tangents. Okay. There is a law of canning them. You can't too much, but you can. That was a bad joke. I know. All right. That's just consequence.
That's
Okay.
the second cancer joke I've heard more than 2 hours.
That's not good. All right. So law of cosines. Now this will work for every triangle if, and we'll fill in the if here in a second. So it works for every triangle if. Okay. Works for every triangle if. Now remember, for the law of sines, we had an if, and that was if we had an angle side pair, right? So the if here is the stipulations that the triangle has to meet in order to use the law of cosines. So what's that if? I said earlier, KHS and EFG. Those are the two triangles we could use law of cosines for. If you look at KHS, all right, or EFG, what types of triangles are they?
Obtuse.
Okay, but it works for acute too. That just happens. That's just by chance. They're both obtuse.
You have to go 2 sides.
In EFG, what do I know?
All the sides.
All the sides, right? So if we know all the sides, right? So if we know all 3 sides, remember last year you guys did triangle congruency theorems? Using all 3 sides was called SSS.
Oh,
Now we're not going to do triangle congruency here, but I'm just using SSS to help us remember all 3 sides. Okay? Or in KHS, how many sides do I know? 2.
So you can find
what's SSA?
Nope. SAS, right? Because we know 2 sides and the included angle. So it works for a triangle if we know all 3 sides, or gonna write or twice. 2 sides and the included angle. And like Lynn said, that's SAS. So that's when we can use law of cosine. So all of our triangle tools, Jared, has specific triangles that work for them. Okay, so SOHCAHTOA has to be a right triangle. Law of cosines has to be all 3 sides or 2 sides and include an angle. And Law of sines has to be a side and the angle opposite, we must know. So, law of cosines. We're going to use triangle ABC as kind of our model for the law. If I'm using this triangle, if this is angle A, then where's little a? The bottom, right? This is little a, right? Where's little b? Okay, between A and C, good. And then little c is the third side, right?
Yeah.
Right? It's kind of a general way to set up a triangle. Now, the law of cosines is little c squared equals a squared plus b squared. Now, some of you are thinking, that's Pythagorean Theorem.
You just switch the
Backwards.
C
Okay.
squared with the
But-
squared.
It's the same thing, right? Now, there's one part we have to put on the end now. Okay? Law of cosines is the Pythagorean Theorem minus 2ab cosine big C.
Is there a song for this one too?
There is not.
Darn, we need to make.
A squared equals C squared.
It's a great idea. You'll see why I'm saying. Okay. So this is the law of cosines. This is a little c or big C?
Little.
Little c. What's this one? Big C. Now, as part of our examples, we're going to find what KS is in triangle KHS. Now, you're probably asking me, well, those are little c's, little b, big little a's, and big c's. Is there any ABCs in this triangle?
No.
No.
KHS.
It's KHS, right? So you can either rewrite the law of cosines with every new triangle you get, which students usually make errors when they do that, or you can rename the vertices and the sides. All right? It's usually easier to rename the vertices and the sides. So when you're using law of cosines, you are allowed to rename sides and angles. All right? You can rename the sides and the angles. Now, when you rename them, don't like cross out and scribble over so you can't tell what it was when we started. Okay? Because in this problem we're trying to find KS. So if you cross out the K and the S so we can't tell what they are, when it comes to telling me what the answer is, you might not know what it is. All right? So as you go through and you rename them, just kind of put a little cross, like one line through it like that, so you can still tell that it's K. All right? Now before you go on, I want you to leave 2 lines here. Okay? We're going to come back and we're going to fill in 2 pieces of information as we work through the next 2 practice problems. All right, so leave 2 lines here. What? What's the question? All right. All right, so triangle KHS. Hey, Jared, if you have a question, please ask. What? Okay. So triangle KHS. Like I said, we are allowed to rename sides and angles, right?
Right.
Okay. Now in this triangle, we want to find this side right here, KS. We want to find that side, right? If I look at the law of cosines, okay, which side do you think is going to be the easiest one to find, A, B, or C?
C.
C. Why C, Travis?
Because it
They give
equals
they gave you the
give
angle.
the angle.
Okay, give you the angle. But if I'm trying to solve this, the easiest thing to solve for is going to be C, right?
Yeah.
Because isn't little c pretty much solved for already? By itself already?
Yeah.
Okay. So if I want to make this problem as easy as possible, then which side should be little c? Should it be KS? Should it be SH? Or should it be HK?
Yes.
KS, that's what I'm trying to find, right? So in order to make this problem as easy as possible, we should make this one KS. We should make that little c. Right? If KS is little c, then what's the H got to be?
Big city.
Big C. Like I said, I'm just putting one little line through it so that I know I renamed it.
Yep.
Okay. Now what's K going to be?
A.
A. Does it matter?
No.
No. If K is A, then what's the 10? Little a. What's S?
B.
B. And what's 4.7?
Little B.
Little b.
Face up.
Does that make sense?
Yeah.
Okay, you are allowed to do that. You can rename the sides and angles whatever you want them to be. All right, I would use A, B, and C because that's what they use in the problem. Now to find little c, we're going to plug into our law of cosines. Right? So little c is by itself, so little c squared equals a squared. What's a? 10. Good. B squared. 4.7 squared. Minus 2 times 10. Bless you. That's 4.7 times cosine of big C. Well, what's big C? 135. Cosine 135. It is. This can be long and daunting. Some people might be intimidated by how long the equation is, but
Whoa.
it's really not too difficult. Okay, just take it piece by piece. All right? Take it piece by piece. Yes, Jasmine.
Where do you get the 2 from?
The 2 comes from the equation.
Oh.
Erica, please pick that up so away, please. I don't know if we're going to mail. I'm going to take it. Okay. So, 10 squared is what? 100. 4.7 squared is 22.09. Mr. Branch is smart, isn't he? He's only done this 3 times. All right. Now 2 times 10 is 20. 20 times 47, or 4.7, sorry, is 94. And the cosine of 135. I want you guys to calculate that one. Cosine 135. Let me know when you get it.
Steve,
45?
no.
Yeah.
0.707.
Good. Now, some of you look like you hesitated when you calculated negative 0.707. When we were doing SOHCAHTOA, I said we couldn't get negatives, right?
Indeed.
I did. Now, when you take cosines of any angle, once the angles get above 90 degrees, then they can start being negative. Okay? So if they're below 90, then they'll be positive. Okay? So since 135 is above 90 degrees, then this number can be negative. And that's okay. All right? So that doesn't tell us that we're in radians now. Make sure we're in degrees before we get started. But if you got negative 0.707, then you are in degrees. Okay? So now that's what c squared equals. So we're going to continue solving for c. We add those together. We get 122.09. 94 times negative 0.707. What's that? What is it?
Negative
Oh, I don't know if I got that.
Negative 66.458.
There we go. So 458, so 46.
Yeah.
Okay. Now we have minus negative. What does minus negative do?
Positive. Add it.
Positive. Right? So we get c squared equals 188.55.
Yeah.
Right? Now how can we solve for c?
Square root.
Square root. Square root both sides. Square root of 188.55.
13.7?
What does it mean?
13.7.
Good. So that's what our C is, 13.7. Now, was it that difficult?
Yeah.
Really?
No.
We just took it piece by piece. It shouldn't be that difficult. Now, some of you like to do as least steps as possible, right? Try to use I can't talk. Some of you like to use as little paper as possible. You don't like doing all these steps,
Correct.
right? You can enter this in one line on your calculator. Okay? If you did that, that's okay. Right? If you want to try it out, you can. If you enter this all in one line, it will work. Okay? Jared looked really excited about that. Okay. So when you do that though, once you get that answer, what do you have to do? What do you have to do at the end? Square root it. So enter this all in, hit enter once, and then square root it, and you get 13.7. All right, so you can try that out. Still seeing the quadratic equation.
You do time cosine or just cosine?
Yep. Well, you can just pretend cosine. You just do 2 times 10 times 4.7 cosine. Now make sure you put a minus sign here, not a negative sign. Okay, minus 2, not negative 2. Like, so we put a -2, then it's going to multiply.
Can't be.
Nice.
Do you 188.55? Yeah. All right. Any questions? Any questions about finding KS? All right, now the second equation. Oh, I forgot what I was going to tell you guys to write down. Remember I said we're allowed to rename sides and angles?
Yeah.
Okay. The first little tip I want to show right there is that if we're trying to find a side, what should the side be?
C.
Little c. Okay. So when you rename it, little c is going to be the unknown side. So if you're trying to find a side, make little c your unknown side. Trying to find a side, make little c your unknown side. This triangle, we're trying to find angle F. Okay, we're trying to find angle F. If I look at our law of cosines, if we look at your law of cosines, how many angles are in the law of cosines equation? How many angles? 2 angles? Okay, Jared's allowed us so far with 3. 1. Okay, good. 1 angle is in our law of cosines equation. Which angle is it? Big C, right? If I want to find an angle, so in this triangle, I want to find angle F, right? If I want to find an angle, then what should that angle be renamed as? Why C, Greg? Because we're trying to find it, okay? Melissa, why do you think C? Because we're trying to find it, okay? Me, why do you think C?
I didn't say I think it's C.
Oh, you didn't? Okay, maybe someone else. Okay. Michael, why do you think C?
Because Greg said we're
Okay, because Greg said we're trying to find it. All right. If I'm trying to find C, if I'm trying to find F, all right, I can find F by finding angle G first, and then using law of sines. Okay? I can find F by finding G and E and then using the angle sum theorem. Right? But we want to make this problem as easy as possible, right? So we want to find F by using one equation. Right? So if I'm going to find F by using one equation, I just want to use the law of cosines once. Right? So that means I'm going to have F be C, because C is the only equation, or the only angle in my law of cosines. So I don't have to use that equation one time. All right? So F will be C.
Big C.
Okay? Yep, big C, because it's an angle. All right? If F is big C, then what's the 10 got to be? Little c. Good. Now, does it matter which one is A or B between E and G? It doesn't matter, does it? Because C is A and B, angle A and angle B, they're not in our equation. So I can call E A, and I can call G B. If E is A, then which side is little a? 8 or 13?
8.
8. Which side is little b then? 13. Okay. So now we're going to use the law of cosines to find an angle instead of a side. Okay? We're going to find an angle this time instead of a side. So what do you think we should add to that second line we left open down here? If little c is my unknown side, then that means big C is always going to be our unknown angle. So when you're using the law of cosines, if you're trying to find a side, let that side be little c. If you're trying to find an angle, let that angle be big C. Okay. So using this equation, using this triangle in the law of cosines, little c is 10, so we have 10 squared equals 8 squared, that's A, plus 13 squared, because that's B, minus 2 times 8 times 13 times the cosine of big C. Did I set that up right? Yeah. What's 10 squared?
100.
100. 8 squared?
64.
13 squared.
169.
2 times 8 times 13?
16 times 13.
16 times 13?
Bar.
208.
Nice job.
So
Nice job.
now we have 100 equals 64 plus 169 minus 208 cosine C. You can see this as a algebra problem now.
Yep.
All right, we're trying to solve for C. If I'm trying to find C, what should I do first? Can I do anything to the left side?
No.
Can I do anything to the right side?
Yeah.
Yeah? What should I do with the right side?
You should
Okay.
add
Combined length terms, you saying add which ones, Michael?
64.
And
169.
anything else?
subtract.
Okay. Every year, I would say a handful of students consistently make an error on this step. Okay. Like terms here are 64 and 169. Right. 208 is not like. 208 has a variable because this is 208 times the cosine of C. C is an unknown, right? So you can almost think of cosine C as like an x. Right? So 208 cosine C, this is not like 64 plus 169. Right? So we need to add the 64 to the 169, and that's all we can do. 233. Students will still make a mistake at this spot too. Okay? They'll see 233 minus 208 and they'll think, oh, I didn't add my like terms yet. And they'll do 233 minus 208
Oh,
and then write 25 cosine C.
bad.
Okay? That's not right either. Okay? Because this still has a variable on it, right? So if I'm going to solve this, which one do I have to move now?
The 100.
233. Okay?
230.
This is a positive 233, so we move it by subtracting 233 from both sides. 100 minus 233 is negative 133. So we have negative 133 equals negative 208 cosine C. I'll write it up over here because I don't know if y'all can see it. Now what should I do? Divide, good. This is multiplication here. We don't add 208. It's multiplication, so we divide by negative 208. We know the negative signs cancel, so we can write it as 133 over 208 equals cosine C. Or you can write the decimal, that's fine. The decimal is point, what's the decimal? 0.639? Okay. You can write it as a decimal 0.639, that's fine. Okay. Now we gotta get rid of the cosine, right? You guys remember how to get rid of the cosine? Inverse cosine. So we take the inverse cosine on both sides. If you're using 0.639, that's okay. This is 0.639. Right, if you calculate the fraction. Right. Now to get rid of the cosine, we do inverse cosine, which means these cancel. Right? And what's the inverse cosine of 133 over 133 over 208? 50 point what? Michael's going to watch the video later just to watch me stumble so many times. So C equals 50.28. And is that an angle or a side? Angle, so it's degrees. Okay. Are there any questions on how I did that one? Now you're probably thinking, whoa, why is that one substantially longer? Right? Why did that one take so much more work, right?
Because it's cooler. It can do that.
Nope, it's not because it's cooler. Okay. Good. Our unknown wasn't by itself. Cosine C is on the side where we have all the extra stuff, right? So we had to do all that work to get the cosine C by itself. Whereas in the first example, it was basically solved for us. Okay. Any questions?
Oh.
No.
Done.
Done.